So here we have my take on the unit circle, which is how I teach it in Algebra 2 and trigonometry. And I make my kids do a whole lot more than just do the unit circle, and we still have the 5-minute time frame. And I'll have kids who can do this whole thing in 2 minutes and 15 seconds flat. A lot of kids get sub 3, and a lot of kids get sub 4. And they actually enjoy this for some odd reason. It's kind of surprising that they do, but they do. Now, the unit circle is built on a couple of things. For one, it's called a unit circle, so the radius is 1. That's a big deal, believe it or not, if it's a teacher that they know that it's 1, because a lot of kids don't. So your easy coordinates here would be 1, 0. Up top, up here, you don't go left or right, 0, 1. Down here, you went left 1, didn't go up or down, so 1, 0. And all the way at the bottom, doesn't look like there's a blank there, but that's going to be 0, negative 1. And I'm always alarmed every year at the number of kids who don't get those things. And a lot of kids get them backwards. I just don't believe that that high a percentage has graph dyslexia, but it's higher than we think apparently. All right, now the rest of this stuff, and I'm just going to do the easy stuff first and I'll do the hard stuff later. We talk about angles. I tell my kids that a big slice of pizza is worth 30 degrees and a little slice of pizza is worth 15 degrees. Now we're going to start at 0 degrees, okay? We're going to add 30, that's going to get us to 30 degrees. We're going to add 15, that's going to be 45. And I've got a little slice still, because 30 then 15 is 45. Next one's going to be 60. And you're at a big slice of pizza, you're going to get up to 90 degrees. And then you've got another big slice, 120, right there. You may not see this at home, but I don't see what you see on the screen. I've just got a blank piece of glass here. We're at 135 degrees. We add 15, we're at 150 degrees. We've just done a semicircle, that's 180 degrees. We've gone halfway around the circle. Big slice, 210. We add 15, 225. We add another 15, we're going to be at 240 degrees. And we're down here, we add 30, we're at 270 degrees. Alright, it's kind of hard to see, sorry about that. Probably spending more time looking down at the laptop than I am actually looking where my marker's at. 270 degrees. Alright, moving on. A big slice was encountered, we're going to be at 300 degrees. A little slice, 315. Another little slice gets us to 330. And then we've gone full circle, we're back to 360. So I've got extra blanks in here for that, full circle. And that really helps kids with the idea of coterminality. If you teach geometry, and I know it's not in Tennessee geometry standards, make your kids memorize unit circle. If you're teaching Algebra 2 at the end, make them learn the unit circle. If it's pre-calc, make them learn the unit circle. Make them learn the unit circle. Force it. Just force that thing. And a lot of kids enjoy doing it. They enjoy the time quizzes, believe it or not. All right, so there's the degrees. Most kids can get the degrees. You still see a couple of kids that struggle with addition, sadly, but most kids do get the angles right. There's something to that. Now, the fun part. Let's do the next thing I kind of want to do is I want to do these ordered pairs, the harder order pairs. Now, the unit circle is built on two special right triangles. One of them is a 45, 45, 90, and this won't be in the right spot because I couldn't format the image just right where I could actually, be able to write into teeny tiny blanks. So we're going to make a 45, 45, 90. And since the unit circle has a radius of 1, we're going to let the hypotenuse be 1. Now 45, 45, 90 theorem says to go from hypotenuse to leg, you divide by root 2. And a lot of kids that I teach in Algebra 2 act like they don't know how to make that look like it's supposed to look. So if you're one of those kids, you multiply top and bottom by root 2 over root 2 because you're really multiplying by 1 because anything divided by itself is 1. And you're going to get root 2 over 2. Now, in geometry, you learned that a pair of congruent angles implies that you have a pair of congruent sides. So if one side is root 2 over 2, the other side is root 2 over 2. Now, where does that come into play on the unit circle? It comes into play on sectors. And I don't want to really mess up the circle I've got in front of me. But you can kind of see I'm tracing this one out right here, that sector. I'm going to redraw that sector. And if you put your 30 and 15 together right here, you'll get 45 degrees. And you'll notice I'm triangling it out. Now, adjacent to a 45-degree angle is a root 2 over 2. Opposite of a 45-degree angle is also a root 2 over 2. And the hypotenuse, which would be the radius of your circle, is 1. Now, to get to this ordered pair, you went right a root of 2, and you went up a root of 2. So that's what's going to go on the circle. So right here at 45 degrees, we're going to see positive root 2 over 2, comma, positive root 2 over 2. That one didn't show up too good through that. Great, did it? Okay, that's a little better. Now, we can use symmetry to get 3 more points for free. So we have x-axis symmetry with 315 degrees. Now, what's going to change is that the x value is going to remain positive, but the y value is going to stay, or going to become, negative. So, got that point for free. We're going to jump over to 135 degrees through symmetry, and the x value is going to become negative, but the y value is going to stay positive. Now, do you know where the next angle with symmetry is? The next angle with symmetry is down here at 225. And in this quadrant, quadrant 3, both x and y are negative. So you end up with negative root 2 over 2, negative root 2 over 2. All right, now the other big thing that we're built on is your 30, 60, 90. So we need to talk about 30, 60, 90 theorem. And by the way, you know, be copying stuff down. Don't just be watching. Watching doesn't do a whole lot of good. You got to hear it. You got to say it. You got to see it. You got to do it. It's more than just watching. So 30, 60, 90 theorem. We're going to let the hypotenuse be 1 because we're using the unit circle that has a radius of 1. And according to 30, 60, 90 theorem, the short leg opposite of 30-degree angle is half the hypotenuse. So half of 1 is 1. Now also according to 30, 60, 90 theorem, the long leg is the short leg times a root of 3. And nobody writes 1/2 root 3. We write root 3 over 2. So how does that help me fill out the rest of the triangle? Well, for starters, you've got this sector right here. It is a 30-degree angle in it. I'm going to redraw it for you. We've got 30 degrees right here. We're going to triangle it out such that a right triangle is made, and that's going to help me figure out that ordered pair. Adjacent to a 30 degrees is a root 3 over 2. Opposite of 30 degree is a 1/2. So to get to that ordered pair, you ran right root 3 over 2, and you went up a half. So I've got a set of ordered pairs here. Right underneath this root 2 over 2, I've got root 3 over 2, comma, 1/2. Now, there's another sector here that's got a 60-degree angle. If I trace it out with this pen right here, it's that one, okay? So let me redraw that sector for you. So maybe you can see where the numbers are coming from. These aren't things that math teachers just make up. They came from a theorem. They came from something you were already supposed to be comfortable with. So it's going to be a much bigger looking sector. But your 60-degree angle is right there. I can never get those blues to work worth a darn. All right, back to the one that always works. We're going to triangle that out, form an imaginary right triangle. It's not really imaginary, we're just going to pretend it's there. Opposite of a 60 degree is a root 3 over 2, and opposite or adjacent to the 60 degree is a half. So to get to that ordered pair, we go right a half and we go up root 3 over 2. So this is going to get me this guy over here. I went right 1/2 and I went up root 3 over 2. And then I'm going to use symmetry, okay? So 60 degrees is symmetrical with 120 degrees. The ordered pair over here is going to be negative 1/2 because x is negative, positive root 3 over 2 because y is positive. Jumping on down to the other thing that has symmetry with that one, and I've got some more to do. I didn't do the pink ones, did I? I'll go back and do them. I kind of got distracted. I'm down here. I can kind of follow the diameter all the way across. So at 270 degrees, both things are going to be negative. Both x and y are negative. There's your ordered pair there. And the other guy I have symmetry with is going to be at 300. And in this quadrant, quadrant 4, the x's are still positive, but the y's are negative. Now, I did forget something. Those guys I did in pink, now there's obviously some stuff that they have symmetry with too. The 30-degree angle has symmetry with the 330-degree angle. It's x-axis symmetry. The x-coordinate is going to stay the same, root 3 over 2. The y-coordinate is going to change signs. We also have symmetry with 120 degrees. But in this quadrant, x is negative, y is positive. We also have symmetry if we just kind of follow the diameter of the circle with 210. And in this quadrant, they are both going to be, and I wrote that backwards. I'm not paying attention. Now am I? Negative root 3 over 2, 1/2. Almost made a big mistake. Negative root 3 over 2, negative 1/2. I don't mind making mistakes with kids because it lets you see that everybody makes them. The thing is that you catch them. So there are all the hard points on a unit circle. The last thing to do is to talk about radians. And I actually just introduced the unit circle before I ever talk about how to convert from degrees to radians. I don't talk about the formula for radians first. I make them memorize the unit circle, and there's so much that they just pick up off of that. So 0 degrees is defined to be 0 pi radians. We use pi rads initially. 180 degrees is a pi rad. Now, if 180 degrees is a singular pi rad, then 360 degrees, and this one's missing a blank, would also be 2 pi. So 0 degrees is 0 pi, 360 is 2 pi. Now, pi is 180 degrees. At least a pi rad is 180 degrees, okay? That means that if I divide it by 2, pi over 2 is 90 degrees. Okay, so I've got something that goes right here. This is pi over 2. Down low, I'm down here at 270. It takes 3 90s to make 270, so it's going to take 3 of those pi over 2s. And the vast majority of kids do fill out those, and they do kind of struggle with the other ones, okay? But they're all based on just kind of logic and math. You think about 30 degrees. If you put 30 over 180, you get 1/6. Now 180 is pi, so 1/6 of pi. 30 degrees is going to be pi over 6 as a rad. We do the same thing with 45. If you put 45, let me put that somewhere where you can see it. If you put 45 over 180, you get a quarter. So hence 45 has to be a quarter of pi. Pi over 4. 60, it takes 2 of these. 2 pi over 6 is pi over 3. And let's get over here to the next quadrant. It takes 2 120 degree angles, or takes 2 60s to be 120, so it's going to take 2 of these pi over 3s. I just keep trying that blue marker and it just keeps disappointing me, doesn't it? Now, it takes 3 45s to be 135. So I need 3 of these pi over 4s. It takes 5 30s to be 150. So I need 5 of these pi over 6s. I'm a little low on room there. 5 pi over 6. When you do the other ones, you can do the same kind of logic here. Like 210 is 7 30s. Okay? I hope you understand that. So in addition to being 210 degrees, it would also be 7 pi over 6. Now, something I do with students, and I think a lot of them use it, is we follow the diameter. And if you follow the diameter, that pi has an understood 1 in front of it. And if you take 1 and you add 6, you get 7. And there's lots of little techniques that other people show you on YouTube. 225 degrees, if you follow the diameter, 1 plus 4 is 5. 5 pi over 4. That was 240 degrees. And if you follow the diameter to 60, you'll see pi over 3. And 1 plus 3 is 4. So 4 pi over 3. Am I missing anything? Got my 3 pi over 2. For some reason, I have erased 270 degrees down here. Not sure why. 300, follow the same trick. You're just going to follow the diameter all the way up to 120. You're going to run into 2 pi over 3. 2 plus 3 is 5. 5 pi over 3. 315, follow that diameter to 3 pi over 4. 7 plus 4 is 3. 7 pi over 4. And do the same thing with 330, follow it to 5 pi over 6. 11 pi over 6. Now, that is the unit circle. That's the way I teach it. There are other shortcuts to it. I'm sure you can find somebody who's got some quick methods too. You know, there's no 5s on this thing. I see a lot of kids draw 5s in the denominator, and there's not a single one in it, so don't be that kid. Now, the rest of my unit circle, I make them memorize everything. Everything. You'd be amazed at how many kids I see walking Algebra 2 that do not understand SOHCAHTOA. They just don't get it. I don't know why. I don't know how you got to my class. Here you are. So classic trig is based off of this, and most, I think, people in this country learn SOHCAHTOA. I think they do. That's the way it's usually taught. I was taught some old horse cutting or the horse taking oats away. But according to SOHCAHTOA, the sine ratio is opposite over hypotenuse. I don't make my kids write opposite and hypotenuse. We just use letters. Cosine, C-A-H, it's A over H. Tangent is opposite over adjacent. Hold on a second. Cosecant is the reciprocal of sine, and cosecant's a hoe. If sine says O, cosecant's a hoe. Secant is a funny guy. It's the reciprocal of cosine. And cotangent is the reciprocal of OA, so it says AO. It's excited. And make them memorize this. Even if you haven't talked about it, make them memorize that. Because if they'll memorize it, they'll understand something by the time you get to it, right? Now the circular approach, I'll just draw a little circle here. And I see a lot of kids actually draw the little circle. And what they'll do is they'll put a triangle in quadrant 1 like I showed them. And they label the x-axis x, the y-axis y, and they label that r. And then they just go through and they kind of do what they did up here. But the sine ratio is y over r. The cosine ratio, adjacent over hypotenuse, x over r. Tangent, opposite over adjacent, y over x. Cosecant is the reciprocal of sine, r over y. Secant is the reciprocal of cosine, r over x. Cotangent is the reciprocal of tangent, so it's x over y. And I also make them learn what r squared is. R squared is Pythagorean theorem. X squared plus y squared equals r squared. I ran out of room there. X squared plus y squared. And the last thing that my kids have to memorize is the signs and the quadrants. So what are the signs in the quadrants? So this is ASTC. That's a familiar mnemonic that a lot of people use. I will say some things in class. The most PG thing I'll ever say is all schools torture children. That's as PG as I'm going to get. I'm just not that teacher. All right, signs and the quadrants. And most math teachers teach ASTC. It's just a simple mnemonic. AS, T, okay, cool, it showed up. And then C, and I can't right there. Hopefully y'all can see that. I can't see it. My laptop's in the way. Cannot see it. But anyways, ASTC. The A says all trig ratios, positive. The S is for sine and its reciprocal cosecant are positive. The T is for tangent and its reciprocal cotangent are positive. And the C is for cosine and its reciprocal secant are positive. Now, I know that some teachers just make them write the letters, but pay attention. A lot of kids don't know what the reciprocal of cosine is. So making them write out both pieces, both the original function and its reciprocal, makes them actually connect dots. That's what the circle quiz is about. The circle quiz is about a student connecting dots. And that's something we're missing in education. They don't connect dots anymore. Everybody wants to be at this whole analyze and create level. It's all built on rote memorization. Make your kids memorize. And if you are a kid, memorize. All right, there's the unit circle, Milbrath style.